Hello everyone, my name is Thomas Kim. Today is June 18th, 2019. This is my 34th video about the future of C++ programming, C++ 2A standard. In this episode, we will learn about parallel algorithm and exception safety. If an exception leaks from parallel algorithm, our application is sure to crash. So we have to prevent exception leaks from our parallel algorithm. In my previous episode 30, I explained about the parallel execution policy. In this video, I said naive, dangerous parallel algorithm. We have to cope with exception leak from parallel algorithm. If you haven't watched this video, please watch it. Also, to follow this episode, please visit extensiontalkplayfun.com website. I updated C++ library extension right before this episode, so please double-click this link to download the complete source code. When download is complete, show in folder, unzip the downloaded file, then copy this folder and paste it to your working directory. In this folder, you can find the tutorials folder. I will post complete source code of this episode to my website. By the time you watch this video, you can download the complete source code. If you are a new visitor to my YouTube channel, then you have to watch this video. If you do not make proper system environment variables, then you cannot follow this episode. Also note that parallel algorithm was introduced to C++ 17 standard, and as of today, June 18th, 2019, Microsoft Visual Studio 2017, Intel C++, and GNU G++ 9.1 support parallel algorithm. If you have older version of C++ compiler, you have to install one of these compilers. If you want to install latest version of Microsoft Visual Studio 2019, please watch this video. If you want to install latest version of Microsoft Visual Studio. Also, if you want to update GNU G++, please watch this video to install or upgrade latest version of GNU G++ compiler. If you want to remove your existing installation and want to reinstall GNU G++ from scratch, please watch this video. If you don't have latest version of C++ compiler, you cannot use parallel algorithm. Now let's get started. In Visual Studio Code, if you open CPP extension, then you can find tutorials folder. Please click this folder. Click this button. O34 exception safe CPP. Hit enter. Ctrl V, Ctrl plus. We will include talk play fun, output HPP, include talk play fun, safe type HPP, include talk play fun, chrono random HPP, include execution for parallel algorithm. If you see this squiggle, then press Ctrl Shift P, edit configuration JSON. Then you have to type in this text. Then save all. Then close it. Now let's understand what's the problem with parallel algorithm. In the global scope, talk play fun, SS stream, I create an instance of stream auto, and there, talk, play, fun, and there, void problem with parallel algorithm. int main, copy this function name, paste it here. Size t, count 10. Auto generator. This is random number generator. Talk, play, fun. Chrono random. Random generator. We are generating integers from 0 to 10. Well, we can say count. std vector int b reserve count. For size ti equals 0, I less than count plus I b in place back generator. We initialize vector b with a count of elements of type int with random numbers. Now we display stream before and sorry, it should be int. Okay, I have to fix this. Now we start command prompt. We created this file in tutorial subfolder, cpp extension tutorial subfolder. dir 034. We created this file. We will start with Microsoft compiler cl ehsc std C++17 034 exception safe cpp fe aexe. Hit enter. So we should build this file successfully. So these are random numbers generated. Okay, from these random numbers we use parallel algorithm std. For each we provide execution policy std execution unsequential. This is execution policy. Then v begin, v end. Okay, then we provide a lambda here like this. We will pass this random generator like this, and auto reference e, we modify e like this generator. So we divide each element of a vector b with random numbers. We divide each element of b with random integer. I will rearrange like this. Stream after. Now we display b once again. In the command prompt we build again cls a, hit enter. It crashed. Okay, it crashed. Now let's see once again. Your application is crashed. If it is not crashed, then this message should be displayed. This is parallel algorithm. In C++ parallel algorithm, if an exception leaks, our program crashes. We have to prevent exception leaks from our parallel algorithm by all means. Now I copy this function up to this point, copy, pasted, and I change the function name, safe way of parallel algorithm. I modify the function name like this, and I copy the function name, copy, pasted it here, and I will disable it. In this section, I declare a variable auto t generator if t is not 0, then d, else we probably have to throw exception, but I will disable it. Throw std exception, but I will disable it for the time being. Ctrl K, Ctrl C. Now we run this function. Now we build once again CLS. Now it works, but this is not perfect. We need to know when it failed. Okay, sometimes it works, sometimes it fails. So to fix this problem, I will introduce here std atomic full operation success true. Okay, then I copy this like this, and I modify this part like this. Operation success false, and here if operation success, then we compute, otherwise operation failed. Okay, then at this point I will delete this. If operation success, then we display the result. Else stream parallel algorithm failed, and then we have to fix like this. If operation fails, we set false, then we bind like this. Now let's run it. We build again CLS. Now parallel algorithm failed. Once again, algorithm failed. In this case, algorithm succeeded. Algorithm succeeded. Algorithm failed. So in parallel algorithm, we have to prevent any exception leak. When we use parallel algorithm, we should never leak exceptions from our parallel algorithm. Another very important point is that any callbacks used with parallel algorithm, we also have to code multithreaded safe way. This is parallel algorithm, and this generator is shared. We capture the generator as reference, and it is shared among multiple threads. So we need to prevent data race using mutex and lock like this. std mutex mutex. This code is incorrect because generate is shared among multiple threads. So std lock guard std mutex lock mutex. Don't forget this. This generator is shared among multiple threads, so we need lockguard. Also in this case, the reason I used atomic operation success is for atomic access. Okay. Also this generator is shared. We need mutex here. std mutex mutex. And in this block we need mutex. std lockguard std mutex lock mutex. Okay, this is very important. Or we can use unique lock too, like this. Unique lock. Then here lock unlock. We have to treat the callback in the parallel algorithm as multi-threaded functions. Now let's build once again. 44. Sorry, we have to pass mutex. And also here we have to capture mutex. CLS. Okay, it's now working correctly and safely. Sometimes in some advanced programming, we need to capture exception from parallel algorithm and have to rethrow. I will copy this function once again. Copied, pasted, safe way of parallel algorithm using exception. Okay, I modified the function name. I copied the function name and paste it here. I will disable it. Scroll up. Now here I will delete this part. I deleted instead std exception ptr exception ptr, null ptr. Actually, we don't need to initialize, but I will just do this. I will capture this exception. Now here we need to try catch like this. Here I will lock like this. std lock guard std mute text lock mute text. If exception ptr is null ptr, then we can proceed. Sd talk play fun safe type safe divide generator. Okay, I will modify like this. Here std lock guard std mute text lock mute text. Exception ptr std current exception. Now I delete this part. Okay, if exception is null, it means exception hasn't occurred. Then we do safe division. It can throw exception, then we lock guard again, then we can access, because this exception ptr is shared among multiple threads. Because exception ptr and generator are shared among multiple threads, we have to prevent data race over these shared resource among multiple threads. So with this, now in this block we don't need lock null ptr, otherwise our operation failed. Okay, so we can rethrow std rethrow exception ptr. We rethrow exception. In this case, now we have to capture exception. Catch constant std exception stream and there I will put carriage return here. Otherwise here operation is successful. Now let's build once again. CLS. Okay, exception is thrown, but the program works correctly. Exception thrown. Now it worked correctly without exception. So this program works perfectly. Before I close this session, I would like to remind you one thing more. First, when we use parallel algorithm, we should never leak exceptions from the callback function used in the parallel algorithm. And second, any callbacks used for the parallel algorithm, we always have to code multi-thread safe way. That is, we should prevent data race. I will talk more about data race in some future sessions. And another thing, very important, is that we should narrow down the locked region as small as possible, which not only improve the performance of our program, but it also reduces the potential of deadlock. So if we scroll down, in this case we use unique lock to narrow down the locked scope like this. In the same manner, here we can use unique lock like this. Unique lock. Then here auto D, because this generator is also shared resource. Then here we modify into D, and before we call lock, unlock. Okay, so we narrow down the locked scope. By using this technique, we can reduce the potential of deadlock, but we can also improve performance of our algorithm. So if you keep these things in mind, then you can take advantage of parallel algorithm successfully. In next episode, I will show you how to create some simple library that would be very handy for parallel programming. Please subscribe to my YouTube channel. Thank you for watching.